to the cloud. All right, yeah. Hi, everyone. Welcome to the next round of an episode of the Auto-remediation working group. This time, I think, or Jürgen and I, we think that it would make sense that we step maybe one step back and think what should we achieve or what do we want to achieve. In the last meetings, let's do a very short recap. At the beginning, we had really good ideas and thoughts, and we were making up this mind map that helped us a lot of ordering our thoughts around auto-remediation. This was in meeting 1 and 2, and we also did a little bit of work in the third meeting. And then we decided that we want to provide a template for a use case. A use case in our situation is a JVM exhaustion, and based on this problem, we want to derive the remediation process that is necessary to fix this particular problem. And in the last 2 meetings, we were discussing this template, and in the last meeting, we then also did a little bit, or we talked about why it's necessary to be tool agnostic when it comes to auto remediation. Because at the end, you always want to exchange the tooling, but without touching the process that you defined. And this is what we discussed the last time. We have
Andrew is also joining.
Andrew.
Hi, Andrew.
Hello, I'm just lurking, just listening in.
Hi, welcome. Great. And this is what I've summarized now, meaning what we have worked on the last couple of meetings and what we have achieved so far, the mind map. Then we also defined the user story and the charter. And last but not least, we talked about the template for the JVM exhaustion example. And this is where we stand right now. And I'm honest with this working group now, and I would like to ask you all of you, what should be actually the outcome that we want to achieve next? And because I think we got a little bit lost with the template and where we are heading towards to, so that we are not focused on what we want to achieve. And I think this should be now an open discussion on what our desired outcome should be in, for example, the next 3 meetings. I mean, we have done quite a lot of work. We have great input, what we have in the mind map, in the template, in the story, but kind of bringing everything together and what should be the outcome is a little bit open and not that clear, I think, right now.
Yeah. I'll say the most exciting thing for me is actually digging into the example case. We chose JVM exhaustion, but it's an interesting dilemma to have JVM exhaustion because it can have multiple different ways of being remediated, and it can have multiple different sources. So of all the things we've done, I think we've kind of got our mission, our charter, and that stuff's fairly good and nailed down. I think the mind map was obviously brainstorming. Anything can go on there. But the thing that seemed to be one of the more exciting conversations we had as a group, at least in this group, was starting to talk about what is the idea for that JVM exhaustion as an example to explore the model or framework for how an auto remediation, that process, what that process looks like, and what are all the steps and decisions along the way in that such a process. Because in the mind map, remember, we talked about permissions and governance of different levels, pre-approved remediations versus remediations that need approval. Well, if we walk through that example of a JVM exhaustion, that'll help us decide where do those decisions take place. How does an organization create those policies? But it's also because it's technically exciting. I mean, to everyone, it was like, all right, now we're getting our hands dirty in an actual problem to remediate. So it makes us feel kind of excited because that's kind of the fun to be like, I didn't have to go through those 45 steps to diagnose, determine, apply, and remediate. and then evaluate whether it worked or not. Like that's a huge process to evaluate and do all that. And Keptn Auto-remediation just did it for me automatically. Whee! So I think that's to me that's the light bulb moment that I think at least excited me about it. At least it's triggered for me the idea of different levels of remediation, meaning the levels of intrusiveness or disruption. How disruptive is a remediation, to the point where I have to do a code change and a push. Maybe a little less than that would be an application configuration change and a push. A little bit less than that would be maybe it's a machine level configuration change, something in the operating system or in the container framework, and push. Or like I don't have to touch any of that. I just need more instances, or I need more of a resource, memory, faster network, something like that. That's at a very, very low level in the infrastructure. Maybe it's even DNS changes. Maybe it's something outside the application stack that would help remediate something. Caching is a good example of that. Something completely separate. The application doesn't even know it's happening, but we're starting to cache things externally. So getting that model to walk through that example, I think is a good, for me, that's an outcome that focuses other things we've talked about onto what that aha, that's cool moment really becomes. And then it's also something that I believe is deliverable. Like, hey, here are the auto-remediation package, if you will, a collection or assembly of things. The auto-remediation assembly for JVM exhaustion. Like we do one for threads, controlling threads. We could do one for general network latency. You could, and at a very general, then get very specific. Here's caching in .NET. You could do that. So you could have very, very narrow scoped packages or assemblies of policies for auto-remediation, very kind of general ones. But to me, walking through that example gets us to those kinds of outcomes. That's the paragraph I wrote in my head just now.
Cool. Yeah. So maybe I just add my thoughts here. So for me, the most interesting discussions were actually what I really liked were around the mind map, to kind of do brainstorming, open up all the different possibilities, all the things that are kind of involved into auto-remediation, to find out, okay, what are maybe let's say organizational boundaries, what are the technical issues which are more related on the infrastructure side, what are the parts that one application has actually to provide to be able to be auto-remediated. Maybe not each application can be auto-remediated. What are the approval steps? So kind of laying out, let's say, a framework, but not a framework in the technical sense and in the implementation sense, but more a framework where you can see, okay, these are all the different parts. And if you want to build auto-remediation, then you have to think about all of these things. And if you want to build it, if you want to implement it, you have to think about those different parts, which are actually the leaves in our mind map, but these are the different aspects. So let's call them aspects. And I also think that doing this, applying this onto an example, gives really a kind of the confirmation that it really makes sense, that it's general applicable, but it does not mean that it's fully in all detail. Maybe it's not fully kind of matured in each detail, but it should be it should give a very good understanding of all the different parts that are involved. Regarding the example itself of the JVM exhaustion, I think it's a very good practical example to do it. For me personally, it's great to see how it works for the JVM exhaustion. Just me personally, I would not go into other examples and then kind of have a look at how I don't know, a process crash would look like, and what are the different options for crashes of processes, and dig deeper there. Maybe this is something where we can have more folks from the working group, or just interested ones, joining and say, okay, now there is this framework. How can we use this framework for my example, and kind of do the exercise that where we provide the framework or the template, and others can then do the exercise and do it, and then maybe we can, as a larger group, maybe then we can come out again with a catalog of different things. But for this group, I would see more a desired outcome on kind of a written way how one can apply the framework that we have kind of developed. This is
Jürgen, not to totally interrupt you, the word model is coming into my brain, but it's more there. When we wrote a book at Microsoft when I was there on ASP.NET, it's one of the old original ASP.NET performance and scalability books, and we, as part of the SQL Server team, cooperating with the IIS team, the ASP.NET team, we had I have PDFs of them somewhere. I'm sure we can find them on the internet. Very, very elaborate flowcharts, logic flowcharts. And of course, they were fairly linear in terms of how you branch your thinking. And there's multiple branches of thinking to remediate. In a very simple example, it was like SQL Server performance. You look at locking, and then you look at blocking, and then you look at resources, and then you look at, and if I'm in a SQL performance, I would go through these steps. And there was a logical sequence, meaning it doesn't make any sense to look at CPU until I resolve these two other issues and bring the data from those two steps into the third step. And so at a very, very low level, you might ask, all right, I looked at locking. At the same time, according to the model and the mind map that we went through, all right, I found something that I can fix. Do I have permissions to fix it? How long will it take to fix it? Is that fit within an SLO or a fixed budget, right? Or an error budget? So there's all kinds of things from our brainstorming model that would come into each step of the process. So I'm connecting the two, just hearing you talk, that there may be another outcome that is sort of, hey, here's some elaborate logic, and making it look huge was great for us because I could increase my bill rate. It was because people would go, holy crap, that's what your brain has to go through to figure out a SQL Server performance problem? Yeah, that's not a deficiency of SQL Server. That's just any database. You have to go through all these steps to figure out how to fix it. And so it was an interesting way to sort of display the complexity of performance, interdependent resources and performance problem identification and remediation, which is, I think we end up talking about it casually, at least I do, because it's just baked in my brain. But if you really spill it out like we did, and we would do, it gets really elaborate. But it could map back to the brain, to the mind map. Say, oh yeah, these are all the different things we had to think about at each step of the process.
Is then the idea that we take the mind map as a basis and then derive a process or a model based on this mind map in a written document, and then we just check the model or check the example we have against the model?
Yeah. And it's like, all right, this example for JVM exhaustion, there's some parts of the model that we didn't have to visit. Meaning, let's say we're remediating something where I don't have to escalate because it's a fairly not disruptive step. Okay, first step, let's say you're going to do you're going to hot swap memory, but it's not available to the operating system until you restart that system. So you could do step one without additional permission. Then step two, you're going to restart that node. So now there's another level of notification in the model where, like, who do I talk to? Do I have permissions? Do we have, that kind of stuff? Is this a highly sensitive application versus pretty much a throwaway part? Can we just throw that container away and fire up another container with more memory? That kind of remediation. But we'd be able to go through each step and say, okay, for JVM exhaustion, we only used 4 of the areas of the model. Let's come up with another example that now goes into, let's, as an example, database indexing, a missing index, very common in almost every RDBMS, and even other issues in NoSQL, you'll find things that are indexes and keys are wrong. You would just pick another example to illustrate other parts of our model, like a high risk part of an application. There may be other controls and permissions, so we have to add, steps or find. So we could find maybe 2 or 3 different examples down the road that would flesh out sort of the whole model. Because I think for all of our thoughts, finding one problem to solve in production that hits all parts of that model might get a little bit crazy, a little bit overwhelming to somebody. I just want the concept. So here's a fairly simple remediation. I need to expand the cluster, add more nodes. Okay, fairly disruptive. We don't have code changes. We don't have config changes. We just need more nodes in a non-elastic, non-auto scaling type of situation. And maybe the remediation is then, last step is recommendation for the future thing we talked about. Hey, did we learn and recommend what we think should be fixed down the road? Hey, get your application to enable auto scaling, with XYZ feature kind of thing. JVM exhaustion is somewhere in the middle, depending on the source of you just don't have enough memory and you need more memory so that GC is working efficiently. That could be it, just limited heap. Or do you have a memory leak somewhere in the application where it's growing and growing? Maybe you have a static structure that's not coded properly and it's just growing and growing over time, depending on throughput. So there could be other things causing a JVM exhaustion that use different parts of the model in the determination of root cause.
Do we have in the mind map some kind of requirements for the application itself? So you just said if there are some issues with JVM memory, then just build the boundaries of this, that it fits, that like GC can come up with a nice way to do the garbage collection. But are there maybe some other prerequisites for applications that they have to be, I don't know, maybe one thing is they have to be stateless, they have to be they have to be available, able to be configured from the outside, or some, maybe like this 12 factor applications, or maybe it's just 3 factors, or maybe it's something else. Maybe I'm not even sure what it is. Or like for infrastructure, it has to be accessible via some kind of infrastructure as code. You have to have infrastructure as code. If there is a manual way to do some things and there's no way to do an API call to kind of approve something, right? If there is always, if you install, I don't know, you do a apt-get install and you cannot do a -y to automatically accept, and the prompt is waiting whole weekend for someone to type in yes, and then so maybe there are some kind of prerequisites for applications that we can also put into this framework.
Sure. Even in a microservices versus monolith type of situation, in microservices, you could tee something up to push, but certain organizations don't allow it to go all the way through because of either a compliance issue or whatever. There is somebody sitting there going, well, it's a manual package drop. Like CD only took us so far, and the zip file sitting right there. All you have to do is double click on it, and it'll go. But then no one's available to do that. So remediation, where we did, I think the mind map to your original question, I think we got to the precipice. We got right to the edge of opening that discussion. And to me, I'm gonna try a little wizardry here for you, if you guys can see this. Do you see this?
Yeah.
To me, it's that level where there's things at a very low level, which is just adding memory, right? At the very bottom. I can take an existing machine, or I can just reconfigure like the app doesn't even know that it just has more memory available, but the container framework would know, or whatever. Even if it's a physical redeployment or no redeployment, hot swap the memory in. I didn't have to call a developer, whatever. I can throw memory at a problem and maybe it buys me something. You just need more memory. And maybe Keptn or auto-remediation would basically do a little diagnosis of saying, we can see where your GC pattern is changing over time. And so we think if you just give us a little more overhead, we're having forced GCs because of heap limitation. But if we give more heap space without changing the JVM configuration or anything, just have more available memory, we can hit that peak and have GC be more intelligent, especially G1 GC in Java 11 and later. G1 really is smart about knowing how to stay. But if you've crunched it, it's like, I really look at these structures. I would really like to have not forced GC because of heap exhaustion. But that's like to me, the model from the mind map would be like level 1. Then let's say you actually had to do JVM config push. If you're, Jürgen, to your point, if config is code, that JVM config has to be pushed back through CD. And maybe I do that change. And because that's more elaborate and a longer process, more people involved, then our mind map where we talk about governments, is this a pre-approved remediation? Has it been tested in pre-prod where everything's a lie? But have we previously passed a quality gate in Keptn to say that is an approved remediation? You can just push the button, and we tested it, which means it doesn't have the -y, and it'll just go tweak the JVM automatically and push different heap settings. If you went further than that, you could get into your more detail, but now you've got app config. So things within the application layer that are on top of the JVM, and that would be like a level 3 remediation. And again, even more permissions. If you took this entire stack and said, I'm going to put this in a high risk app, I've got additional steps at each of those to get permissions, to get, notifications change. Oh, this is a high risk app. Even if we think it's benign and it was a pre-approved remediation, we're going to give a notification to the app stakeholders to say, oh, hey, one of our high risk apps, high revenue generating, high dependencies, went through a change that is supposedly benign. And here are extra information about what to do if something doesn't seem right, who to call, et cetera, et cetera. So there's other steps in our mind map thinking that would play over here, whereas a low risk app, let's say this is medium and this is low risk app, we could do all 3 levels of remediation over here in low risk without any extra notification. Didn't have to call anyone, nothing. We just take care of that app and keep it running. In the medium side, maybe when it gets to app config, we need the technical product owner gets a notification, and maybe the lead technical dev, gets invited to a 15-minute, hey, can you be on call while we push this app config change, et cetera, et cetera. So that's the idea where, for me, walking through an example with different levels allows you to say, hey, here's where I would not have to use a lot of our thinking in a very elaborate mind map, whereas high risk or compliance or high throughput, high risk could be high throughput as well. It's under tremendous load, extra steps for load balancers, pull a container out completely, smoke test it before we put it back in, et cetera, et cetera. That has other more elaborate steps. And I got to use my picture in a picture.
Yeah.
Yeah,
Keptn. Yeah, I really think that these concepts can really understand the whole complexity of auto-remediation. And I think at the very beginning, it was never a goal to do the whole implementation. The goal was always to showcase what is part of what has to be part of a modern auto-remediation tool, so to say, something that is not existing yet. So we don't have to focus on Keptn how it is right now. We should focus on how we need to build it. And helping with all these examples, I think it really helps if we can think about, okay, where is this classification of low, medium, high risk, for example? Is it only in the remediation part? Maybe it's already in the deployment part. Maybe it's in the whole application lifecycle part. Maybe high-risk applications need to be, let's say for high-risk application, we enforce security scans during deployment. So this could be one of the things where Keptn already takes care of this. I know now I'm again talking about Keptn, but it's just something that it's not only for the remediation part.
Yeah.
And then it gives a justification why it's so important for remediation, because it's not only important for remediation. So we really have to put this into the concept of also in remediation, because it's actually the whole application lifecycle. If we think of a rollback, then maybe a high-risk application has to be treated completely differently in a rollback, because manual approvals are needed, and they are needed because it's of high risk.
Yeah.
And this also kind of involves then the deployment already in the first place.
Yeah. I think I obviously lean heavily into Keptn's definition, I would say definition, but implementation of the quality gate concept, because that's near and dear to my heart, or it's in my experience, in my mind more than anything. And if you're not using Keptn to do quality gates, you might be doing that in very old school ways. You might have a fairly elaborate quality gate concept on your pipeline. The other question that expands for me on that, and the reason I see Keptn quality gates and the automation of your pipeline working in tandem, is because you have multiple pipelines flowing into an entire app landscape. And so you're doing auto remediation, not just on a single pipeline. You've got to go back and say, oh, well, wait a minute, I can make this change, but that also infects this dependency, this dependency. Database indexing is a good example. If I just go, hey, this application uses this table for this index, but there's 40 other applications that hit that same table. Okay, because we still have a monolithic database or a centralized database concept. Okay, I can't just tweak this index for me. Now I'm hitting some other roadblocks in the idea of auto remediating a missing index. I've got there's an index there already that covers 5 of the 6 attributes that I need. I can just add the 6th in there because it may affect that other application's query. This is really what we pay the human brain to do all day long as a DBA designer, developer, modeler. It's like, all right, I'm going to figure out how many different stored procedures to talk to account data can I really support under different workloads? And do I need to split them out? I have 3 different account tables now in the NoSQL world. They have some similar data. When I need to coalesce all those tables and go do reporting somewhere, that's a whole separate process. So there's different ways to solve that problem of that layered interdependency. To me, that's where remediation generally gets really complex. So we picked a fairly simple one, even JVM exhaustion, but when you think about it in that context, it quickly gets more complex, even when you start applying our thinking on it. Anyway. So to summarize that back to Jürgen's point, I think there's more we can do in the mind map that helps us go into different modalities of remediation, highly interdependent versus low interdependence, high permission versus low permissions, meaning manual intervention for permissions, high pre-validated remediation steps versus low pre-validated, meaning have these changes ever gone through the quality steps or quality gates to say, hey, we're pretty comfortable in our experience about changing JVM settings. We've done a lot of them over the years. We're just going to tweak this one like all the other applications. So that previous experience, prior knowledge, permissions, things like that could go into the mind map, and maybe that does become a model. And I think there is, to me, there's still a flow chart in there. There's what are all the things I have to go through as almost a checklist before I take any action or even try an action. The other thing you think about the Akamas guys, I mean, they'll put in a setting, they'll run something, and they'll get the data back. You could even do in production, say, well, of the 16 different containers, we're going to tweak it and move one of them, put a little traffic onto there, monitor that, and then see if that change is good. That's like when you're developing the remediation. There's even people that under pressure are like, well, let's try one, see how it goes. If that looks good, we'll push it across all the rest of the containers and restart them. So that's a whole other different kind of way of doing remediation in real time.
I even think about it. So, sorry for interruption, but
no, it's good.
I even think about this kind of that remediation is also an optimization problem. If we think about remediation not remediating the user impact, like an outage or a high error rate, so I cannot do my checkout and I really want to get this, I don't know what I want to buy, like more coffee beans. But we could also think about auto-remediation as it's not meeting SLOs, and the SLOs are defined as running very performant. Like the Acamas guys, they are always optimizing the JVM settings. So maybe if we're not hitting our SLOs, we treat it as an auto-remediation problem. So we could go back and forth with auto-remediation to kind of do auto-remediation steps. It would be more on the low impact part and would hopefully go without approvals. But this kind of doing one thing, giving it a try, testing it, then evaluating it, doing another thing, giving it a try, then evaluating it. It's basically, it's the same workflow, or it's the same flow chart for auto-remediation as well. Just the trigger is not an incident or an issue or a problem, but the trigger is because we failed our SLOs that are specifically only made for optimizing the application. So it could also be like on the, it's not the core problem, but it's the same idea, optimization as a remediation problem.
What about something famous from about 10 years ago was this idea of cost optimization, which was, if you're looking at something in like cloud or abstraction layer in the cloud, hey, it's cheaper to run my containers over on those guys than it is on these guys. They announce a pricing change, and like if you put the cost of the platform, cost of the infrastructure into the model, could I just don't change a line of code? No one even knows. Hey, we're running on these containers over here. We're running on that provider over there. So there's not even the upside is not great performance. It's just same performance costs you $1,000 less a month.
Mm-hmm. That's actually what they the folks at Auto-rate are doing. You've heard of them. So Auto-rate is I think of it, it's a little bit of a Keptn quality gate, but they don't call it the quality gate, but they more want to do like A/B testing, canary releases, more. They say Auto-rate makes it easy to optimize business metrics and validate SLOs when you release new versions of Kubernetes apps. So
I think you're right. There is that should be in the model. You know, what is the impetus? What is the motivation? Is it, and then it could be, you know, refinement or, like you say, optimization as iterating on the continued. We've been remediating this same way the entire time, but is there a feedback mechanism that says, you know, every time we do that, we should wait longer between changing the load balancer and then give it more time, or there's very technical ways of refining that. But then to these other goals, does it change conversion rate, the A/B testing? Honest to God, that kind of testing, I always think you're right. Just, it should be one of many quality gates. It's not coming from a hard requirement. It's coming from our friends call it a desirement. I desire to make more money. I desire to have a better conversion rate. I desire really nice colors, or you know, on my website, I want to change my colors, but you know what? Suddenly some graphics engine just goes, it looks terrible. So optimize other telemetry.
Yeah, you could optimize for availability or for revenue. So
sure.
Of course, you need some kind of availability for revenue, but or like
but I mean, it can also be a sentiment, right? We know that's a big thing. You know, if you've got feedback mechanisms on your website, so we made some changes, and unrelated to the change, people I had a 10% uptick in people that said your website is great. Awesome. Okay, cool.
Goes a little
Okay.
bit into the direction of the business objectives where we talked about this one.
Yep.
Yeah, as we were working on the mind map. All right, gentlemen, what should be the next step?
So I would, sorry, I just have to put down my phone. I would suggest to take the mind map, put it into a written document, because right now all the leaves, they're just the bullet points. We know what we mean with it, but I think adding a sentence or two for each of them would be, we already come up with a kind of a large document with just the description of the mind map. And then once we have this, we can go on to the template. And Johannes and I, we already did a couple, we used this template already today and put in the tools, for example, which are used, because this was also one of the action items from last meeting. I think today we have discussed, it's not about the tools, it should be nevertheless tool agnostic, and that can be later on, it can be a nice framework for us to find in the ecosystem, what are the tools, what are they doing now nowadays, and then reach out to them and invite them also back to this working group, or maybe we initiate a new working group under a new umbrella or whatever,
or a working session specific to what they do. Like Iterate's a great example. Akamas a great example. They're already a partner. To like, hey, we want to take what you do and try it out in this new model and get some feedback from them.
We were discussing today that also that there are these special interest groups that are part of the CNCF, and maybe so this could be something where we then open up a little bit more and ask others, okay, can you please present how you are doing this? Does it fit to the model that we've already developed? Does it, or do we need to extend the model? Maybe we've only seen this from one angle and one perspective. I think we had already great discussions here, so I would pretty much be surprised if we missed one part, if we totally missed one part. But having this and then giving this as a kind of as an input for further discussions could really help. But I think for this first, to have a written document, do the mind mapping, describe all the leaves, and then all the other parts of the mind map. Also describe the template. I think Kevin has also done a great job here in describing everything that was going on in their organization, very detailed. Mark, you have also done this great job on the user story that can fill in here. So I think we already have something. Me personally, I would start with describing the concepts of the mind map, because this will give us the model. Then we can use the model for the template. We have the example for it, and this could be something. I think it might be way too long for a blog article, but like a lot of working groups, they then come up with a white paper at the end. It can also be a blog article. It can be whatever, but it's something to share then with others that have not been yet part of this working group, so that we can also get their feedback, and we can use this eventually also as part of a new implementation, or a further implementation improvement in Keptn. But also to it's a food for thought for the whole community.
So things that would go in that document, Jürgen, I think I see maybe a block, like a flow chart, but it's also without process flow. There could be like a block model. What are the building blocks that are all part that you have to think about? Like when I go in to remediate problems, I kind of, it's like I could go anywhere I need to within these different considerations for, well, what application does this touch? What another thing we could do in the paper are, here's the, a checklist of questions that would even be inputs to something in an automated auto-remediation product.
Process.
Yeah, process would be you're always ingesting information that tells you, okay, here are the blocks of the model that are going to be most important for what you're dealing with. And the third so block model, I think there's a list of questions for ingestion. What are the questions? What are the data points, the data inputs to the model that help you, navigate? When I show up with a customer as a human to do this, it always starts in the first n number of hours with gathering data, gathering information, and pulling them into my brain model, and then figuring out exactly, then I ask this, loop back on questions. All right, I see what could be the thing. Is this something we try? Is this something that I know will fix it? How confidence? So that makes me think of the vectors, meaning in our model here again, the vector was low, medium, high, and I just said risk. So risk would be a vector. Permission or experience would be, we're very experienced in tweaking JVMs. We've been doing it for 20 years. We know a lot about it. So we can automate that knowledge on a vector. Disruption would be another one. Dependencies would be these different vectors. I think we describe them as, when I'm looking at the block model, are some of those blocks more complex, less complex, more sensitive or less sensitive given the environment? Because you could walk into another system and say, well, there's very low dependencies because we're in microservices and we can make changes without really putting at risk the majority of the monolith. But if I walk into a more monolithic application, I'm like, well, you know what, this is the Jenga tower. I can't just go pulling pieces out and starting to try to fix things. There has to be extra testing, maybe extra retries before simple rollout stuff. So I think that those could be some of the things we write up in terms of the model, how it would visually appear, a flow chart to how to apply it. Because once you take an abstract model, apply it to the step-by-steps, now you're going through the logic flow. Vectors, what data points to be ingested, and those could blog articles could come out of each of those. You could just say, hey, here are the top 10 questions that we ask when we're going to start to build auto remediation engine. What kinds of data inputs do we need? We start with some questions.
And as I'm listening now and ordering my thoughts, I always have this chart in my mind that has 4 quarters, and with two angles, 2 directions, and we can also put different vectors, or can use the vectors. Maybe one is for risk and the other one for dependencies, and then depending on in which quarter you are in, maybe other recommendations and aspects you need to consider. And we could kind of provide this quadrant. It's a quadrant, and tell then the reader or the person that is interested in which aspect is relevant when you are in which quarter, as a kind of recommendation model.
I think also with that, because I know it's not just a XY 2-dimensional quadrant math.
Yeah, it's
I ended up in this square, and in this square there's a 3-dimensional quadrant of, I'm going to disrupt and then whatever. So now you can have one of 3. You can either have a really secure system, a really performant system, or make your boss really angry because you took a bunch of risk without their permission. But I think I think that's to communicate something simple and then ease people into the idea of now you've gone through this first quadrant map to figure out where you are. Let's double click on that and drill down and look at, now you've got these other things at the next level of complexity, which is, I think, what makes this area of, first of all, it's the exciting thing to me is just how your brain works to go through this. And if you've done it a couple thousand times in your career, I don't often stop to even stop my own brain. It's like, I'm crossing. The most interesting things are the stuff that I apply apathy. Like, what are the things that I feel safe that I can put out of scope? Okay, I know I'm not going to touch X because that has nothing to do with my next hypothesis to go down and fix something. So there's even like a whole other article. Maybe maybe I'll give a talk about this. Like, I don't care. I like apathy as as my guiding light. I go into a situation where I'm nervous and I care about everything, and then I process of elimination. Here's all the things I don't care about, and then get to the root of something. So maybe there's a whole other inverted thing. Instead of, hey, we need to expand everything we're aware of, you also need to know how to safely ignore stuff.
Yeah, we just had a talk recording today with our friends from Litmus Chaos, and they also had this the known knowns, the known unknowns, the unknown knowns, and the unknown unknowns, and where kind of why it is so important to also test your applications, to always assume, or it was the other way around. We always assume what are we have a lot of assumptions when we develop applications. We assume we always have network. We assume we always have power. We assume we always have unlimited CPU. So a developer would not assume his application would just be moved from one node to the other, and during this process it will not be available. This is not what the developer thinks. The developer has some assumptions that if I build my Docker container, whatever, and it runs, then it will always run, because there will always be a safe place for it. But that's not the case. So this kind of, we work a lot with assumptions, and then also with a lot of unknown unknowns, basically, or known unknowns. But
the epistemological model for chaos. I gave a talk once about that. That was the known knowns, the known unknown. It was about precognition in your experience of interacting with an application while you're testing, doing exploratory testing. It was like, there's stuff I'm not even aware of that I'm thinking as I do this, and how do I tap into the stuff I don't know, but I know it's in there, and then the stuff I don't know that I don't know is in there while I'm anyway. Cool. So does that help us, Johannes, get to narrowing down on kind of what we would like to produce?
I think what we discussed right now is two aspects. First of all, we derive a model or framework from the mind map we have. Just took a couple of notes how the model, or what the model should contain, and then based on that we do an example based on the JVM exhaustion scenario to validate how the model fits in, or how the model fits and how it fulfills then the requirements. And I think this makes totally sense, because it summarizes the work we did at the beginning and what we did the last two meetings, to have then written document and something that we can collaborate and we can share with others. Absolutely. I have to leave the building in 2 minutes, but I really would like to define what we should work on the next 2 weeks. I mean, I can contribute on working on building the model, the framework, by taking the mind map and providing an outline first, and ordering the thoughts that we have there. This is something that I can contribute and work on.
I can definitely, I would like to do a few more of these, just and then go back and find stuff that's coming out of my brain and go flesh them, like actually take what's on the mind map, like work backwards from the example, which is, I think, the reason we wanted to do an example anyway. So let's go through what we think that process is and see if we can find our way back home to what the block model is. And then let's throw out a kind of a generic outline for what we think the white paper, or what the report would look like, and kind of the different sections that we want to dig into, and that'll kind of lay out generically as an outline where we can start writing, and then editing and tying them back together. And I think our objective, the way we look at the charter, that kind of deliverable fits with what we want to contribute to the industry, right? Some pretty in-depth thinking on how you would model this out. So I'm good with that. And in next 2 weeks, I'm pretty good. I think I don't have any. Yeah, I don't have any customer. Hopefully, I don't have any escalations, but I don't have any key customers on my plate right now.
All right.
I do have to spend 10 minutes writing something for Andreas, but you know.
And may I ask you to help out a little bit on writing the framework, the model?
Yes, sure.
Okay.
Oh, sorry. Whoops. He's just watching my hand.
No worries. Cool. Yeah, I also need to jump here. But I think it was a very very open discussion today. A lot of new thoughts, and I'm really looking forward to bring this all together into this model.
I'll let you guys go. I would think maybe, given that we only had a handful of us here today, and we started with more folks, maybe we find a way to get even an update of what we're working on once we have something that's a little more visual or written up, to kind of bring it back out to the major working group or the advisory board and say, hey, just share an update of what we're doing.
Absolutely.
True. When we have something in hand, then let's share it to make us more visible then.
Okay.
Can I just ask, by the way, what the companies you mentioned today was Acamas and some others?
Iterate, right?
Yeah.
Iterate.
Iterate. It's not a company. It's also it's an open. I think it's also open source project. I just had it open earlier. Let me just iterate.tools. I will just send it to you here in the Zoom chat real quick. So here in the Zoom chat, and the company was called Acamas. I think they're based in Italy, or at least they have some Italian roots.
So Acamas, they're kind of like Stormforge, if you've seen those. It's a different performance optimization company.
But I was not. Did we mention anything else? So it's.
What was the other one?
Stormforge. I just saw we had a discussion internally, and they're pretty similar to Acamas.
Okay. They try out different settings for frameworks and performance optimization and stuff. Yeah.
Yeah, basically it's AI ML based optimization based upon Prometheus.
Yeah. No, that's right. I remember. I saw a white paper from them. Very cool. Yeah, it's the other Jürgen. I think they call it loop testing, where they're trying different stuff, and like you say, for A/B and that kind of stuff. But Johannes has to drop. He's going to get out of here.
Okay.
Unfortunately, I'm very sorry. But
cool. Okay, cool.
That's great.
Awesome. See you all next time.
Thank you guys. Take care.
Bye.
Yeah, bye.
Bye-bye.
Bye.